Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 20 video on the chapter of mensuration where I will solve the next 10 problems, that is problem number 11 to 20 of exercise 20D from the textbook of author RS Aggarwal. So these problems are based on area of a triangle. If you have not watched the previous videos, part 1 to part 19, based on this chapter of mensuration, then I strongly suggest that you please also watch those videos to maintain the continuity of your study on the chapter of mensuration. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 20 video on the chapter of mensuration, where I will solve question number 11 to 20 of exercise 20D from the textbook of author RS Aggarwal. Okay, so as usual on the left hand side I have kept my quick notes based on the area of a triangle in case I forget any formula. On the right hand side I have already written down the problems 11 to 20 where I will solve the problems, and I have also written down the answer so that I can match my solution with the textbook answer. Okay, so let's start solving the problem. Question number 11 says the area of an equilateral triangle is 16 into root 3 centimeter square. Find the length of each side of the triangle. If we know that for an equilateral triangle, we know that the area, we know that for an equilateral triangle, the area is equal to, there is a formula, square root of 3 divided by 4 multiplied by a square, where a is the length of each side of the equilateral triangle. So in this problem, it is given, area is already given, and we have to find the length of each side. So we have to find the a. Okay, so we have a is given to be 16 multiplied by square root of 3, this much centimeter square, is equal to square root of 3 divided by 4 a square. So this implies actually this will be centimeter square. So this implies we can ignore centimeter square, the unit, from both sides and just equate the value, and we get a square is equal to 4 by root 3 multiplied by 16 multiplied by root 3, this much centimeter square. So after simplification, this will be 64 centimeter square. So we have a square is equal to 64 centimeter square. So this implies a will be equal to square root of 64, this much centimeter, which is equal to 8 centimeter. So this was directly based on the formula of an area of an equilateral triangle to be square root of 3 divided by 4 multiplied by a square, where a is the length of each side of the equilateral triangle. Let's see the next problem. Question number 12. Find the length of the height of an equilateral triangle of side 24 centimeter. Now, okay, so how do we find the height? Remember that in a triangle there are three heights based on which side you are considering as the base. So for each side as a base there is a corresponding height, but in an equilateral triangle all those heights, three sides, are of same length. Because it's an equilateral triangle, the sides of the triangle are equal. That is why the heights of all the equilateral triangle, the three heights of an equilateral triangle is same. So an equilateral triangle has a single height. Okay. Now how do we find the height? There is also a formula height based on the each side of the length of each side of an equilateral triangle, but we can also find the height using the formula of formula of area of an equilateral triangle. So area will be, we know that the area of an equilateral triangle is square root of 3 divided by 4 a square, where a is the length of each side of the equilateral triangle. In this problem, length of each side is given to be 24 centimeter. So this will be square root of 3 divided by 4 multiplied by 24 square, will be centimeter square. Okay, so this is equal to 24 multiplied by 6 multiplied by square root of 3, this much centimeter square. Okay, so area is 24 multiplied by 6 multiplied by square root of 3 centimeter square. Okay, so we have to find the height of the equilateral triangle. Okay, now we also know that area of a triangle is equal to half the base into height. Now for an equilateral triangle, the base is, all the bases are same, since all the sides of an equilateral triangle are of equal length. So we can say this is equal to half. The base means the each side of the equilateral triangle, which is 24, multiplied by height. This implies area we have already calculated to be 24 multiplied by 6 multiplied by square root of 3 should be equal to half multiplied by 24 multiplied by height. So from here we can easily find the height of the equilateral triangle. Height will be equal to 24 will cancel out from both the sides, and height will be 12 root 3 centimeter square. This is equal to 12 multiplied by the value of square root of 3 is has been given to be 1.73. So this is 1.73 multiplied by 12 centimeter. And now to calculate this, I am using the calculator. I am sorry for this. Always do the calculation with your hand, by hand. 20.76. So 20.76 centimeter is the height of the equilateral triangle. Okay, let's see the next problem. Question number 13. Find the area of a triangle in which all the sides are, there are three parts, all the sides are given. So definitely we have to use the Heron's formula to find the area of the triangle. Part 1, A is 13 meter, B is 14 meter, and C is 15 meter. So we know that for area we need to find the semi perimeter small s, which is equal to half of the sum of the sides of the sum of the length of the sides of the triangle divided by 2. So what will be small s for part 1? It will be A plus B plus C, and I also forgot to write down the answer. Anyway, so smallest is A plus B plus C by 2, which is equal to 13 plus 14 plus 15 divided by 2 meter, which is equal to 27, and 42 by 21. So this is 21, S is 21 meter. Uh, 72. Okay. So therefore area will be equal to square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. This is equal to, what is S? S is 21, and what is S minus A? S minus A is 21 minus 13, 21 minus 14, and 21 minus 15. Area should be this much meter square. This is equal to square root of 21 multiplied by 8 multiplied by 7 multiplied by 6. Okay, this much meter square. This is equal to 21 is 7 into 3, 8 is 2 into 4, we have 7, and 6 is 2 into 3. We have to form squares inside the square root. So we have 2 square multiplied by 3 square multiplied by 4 multiplied by 7 square, this much meter square. So this is equal to 2 multiplied by 3 multiplied by 2 multiplied by 7, this much meter square, which is equal to 612, 84 meter square. Now, if I am doing any kind of calculation mistake for this problem, I have forgot to write the answers. Okay, if I am doing any calculation mistake and I am getting any wrong answers, then please do let me know in the comment section. I will appreciate that. So that was part 1. Now I think I need not do the part 2 and 3. They are quite similar. It is just you have to find the smallest, which is the semi perimeter, which is a plus b plus c by 2, and then apply the Heron's formula. I use the Heron's formula to find the area. So I am not doing part 2 and part 3. Okay, let's do the next problem. Question number 14 says the lengths of the sides of a triangle are 33 centimeter, 44 centimeter, and 55 centimeter. Find the area of the triangle and hence find the height corresponding to the side 44 centimeter. Okay, so we know the Heron's formula. We have to find the semi perimeter, which is a plus the sum of the length of the sides divided by 2, which is equal to 33 plus 44 plus 55 by 2 centimeter, which will be equal to, if I take 11 common from all of them, I will have 3 plus 4 plus 5, which is 7, 12. So this is basically 11 into 12 by 2 centimeter, which is equal to 66 centimeter. 66 centimeter is the semi perimeter. Okay, so now the area will be equal to square root of s multiplied by s minus a multiplied by s minus b multiplied by s minus c, this much centimeter square. So this is equal to s is 66 multiplied by 66 minus 33 multiplied by 66 minus 44 multiplied by 66 minus 55, this much centimeter square. So this is equal to 66 multiplied by 33 multiplied by 22 multiplied by 11, this much centimeter square, and this is equal to 66 is 11 multiplied by 6, 33 is 11 multiplied by 3, and 22 is 11 multiplied by 2, and we have 11 centimeter square. So let's form squares of the numbers inside the square root. 11 is how many times? 1, 2, 3, 4. So 11 we have 11 is 4 times, so this will be 11 square, and then again whole square. Square of 11 square multiplied by okay, so we have 6 multiplied by 3 multiplied by 2, which is 36. So 6 square, so this much centimeter square. So this is equal to 11 square multiplied by 6 centimeter square, which is equal to 121 multiplied by 6 centimeter square, which is equal to 726 centimeter square is the area of the triangle. Now we have to find the height of the corresponding to the side 44 centimeter, and there is no space. Okay, so we know that area, so we will have, if we consider the height as h corresponding to the side of length 44 centimeter, we must have 726 should be equal to half multiplied by 44, that is the base, and the height be h. From here we will get height. So this implies height is equal to 726 multiplied by 2 divided by 44, and this is equal to, I am again using the calculator, 726 multiplied by 2 divided by 44 is 33. So this is 33 centimeter. So the height of the triangle corresponding to the side of length 44 centimeter is 33 centimeter. Okay, let's do the next problem. Question number 15. The sides of a triangle are in the ratio 13 is to 14 is to 15 and its perimeter is 84 centimeter. Find the area of the triangle. Now we know, so the ratio of the length of the sides of a triangle is given and the perimeter is also given. So we can, using the concept of ratio and proportion, we can easily find the sides of the triangle, and then we can, once the sides of the triangle is known, we can use Heron's formula to find the area. Okay, so let the sides be based on the given ratio 13x. Since the perimeter is given in centimeter, so let's say let the sides be 13x centimeter, 14x centimeter, and 15x centimeter. So this implies perimeter is equal to 13x plus 14x plus 15x, this much centimeter, which is equal to 42x centimeter. The perimeter is given to be 84 centimeter, so we can say 42x is equal to 84. So this implies x is equal to 84 divided by 42, which is equal to 2. So this implies the sides are, let's say A be equal to 13x, x is 2 centimeter, which is equal to 26 centimeter, and B is equal to 14x, so 14 into 2 centimeter, which is 28 centimeter, and C is equal to 15x, so 15 into 2 centimeter, which is equal to 30 centimeter. Okay, so what will be the semi perimeter? Semi perimeter is A plus B plus C by 2, which is equal to 26 plus 28 plus 30 by 2 centimeter, which is equal to 13 plus 14 plus 15. Okay, so this is equal to, I guess, 42 centimeter. Okay, this implies the area of the triangle will be S into S minus A, S minus B, S minus C, this much centimeter square, and this is equal to, S is 42, 42 minus 26, 42 minus 28, and 42 minus 30. This is equal to, so this much centimeter square. So this is equal to 42 multiplied by 16 multiplied by 14 multiplied by 12. centimeter square. So this is equal to 42. Okay, 42 is 7 into 6. Okay, okay. So 42 is 7 into 6. We have 16, which is 4 square. 14 is 2 multiplied by 7, and 12 is 2 multiplied by 6. Yes. Let's form squares of numbers inside the square root. We have 7 into 7, which is 7 square. We have 6 into 6, 6 squares. We have 4 squares, and we have 2 squares. So this is equal to 7 into 6 multiplied by 4 multiplied by 2, this much centimeter square. This is equal to 48. How much is 48 multiplied by 7? That is 336. So the area of the triangle is 336 centimeter square. Okay. Let's do the next problem. Question number 16. The sides of a triangle are 42 centimeter, 34 centimeter, and 20 centimeter. Calculate the area and the length of the height of the longest side. And the length of the height, and the length of the height of the longest side, which means that you have to find the corresponding height corresponding to the longest side of the triangle, which is 42 centimeter. So we have to find the height of the triangle considering 42 centimeter, the side of length 42 centimeter as the base. Okay, so let's first calculate the semi perimeter as A plus B plus C by 2, which is equal to 42 plus 34 plus 20 divided by 2, this much centimeter, which is equal to 21 plus 17. 21 plus 17 is 38, and then 48 centimeter. Therefore area is equal to square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C, this much centimeter square. This is S is 48 multiplied by 48 minus 42 multiplied by 48 minus 34 and 48 minus 20, this much centimeter square. This is equal to 48 multiplied by 6 multiplied by 14 multiplied by 28, this much centimeter square. This is equal to 48. 48 is 8 into 6. 8 into 6. We need 7. Okay. 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 So let's see. Into 6 into 2 into 7 into 7 into 3 centimeter square. So this is equal to, we have 2 6. So definitely we have 7 square, and we have 6 square and 2 16. 6 square, we have 1 3. 7, sorry, this will not be 3, but we have 7 into 4. Okay, so now we have multiplied by 6 square multiplied by 8 square. So this is equal to 7 multiplied by 6 multiplied by 8, this much centimeter square, and this is equal to 42 multiplied by 8 is 336. So this is 336 centimeter square. So now we have to find the area, we have to find the height of the triangle corresponding to the side of length 42 centimeter. So we have 36 area is equal to half the side. If we consider 42, the side of length 42 centimeter as the base, and we have height, h is the height corresponding to the side of length 42. So this will imply h is equal to 336 multiplied by 2 divided by 42, this much centimeter, and which is equal to multiplied by 2 divided by 42 is 16. So the height is 16 and the area is 336 centimeter square. Okay, let's do the next problem. The base of an isosceles triangle is 48 centimeter and one of its equal side is 30 centimeter. Find the area of the triangle. Okay, so we already discussed about the area of an isosceles triangle and the relation between the base, which is y, and we on the left hand side in the quick notes I have referred x as the length of each equal side of an isosceles triangle, h as the height, and y as the base. So we clearly see that the area of the triangle ABC is half hy. In the problem, x is given, and the base y is also given. The y is given. So if you consider an isosceles triangle ABC, it's ABC with the isosceles triangle where the equal sides are of length x, where x is given to be 30 centimeter, and the base of an isosceles triangle is 48 centimeter. So this one let's consider as y. So y is given as 48 centimeter. It is asking to find the area. To find the area, we need the height corresponding to the base. That is, we need the value of h. We need the value of h. So we have the formula, as you can see on the left hand side, y square is equal to 4 into x square minus h square. From here, since we know y and x, we have to find h. So h square will be equal to y square by 4. It will be, what will be h square? H square will be x square minus y square by 4. Okay. So this is equal to, what is x is 30 square minus y square is 48 square by 4. So we have to compute this. How do we compute this? 30 square minus 48 square by 4. Okay. 12. So this is 900 minus 48 multiplied by 48 divided by 4. So 4 cancels with 12. So this is 900 minus, I'm again using the calculator, 48 multiplied by 12 is 48 multiplied by 12 is 576, minus 900 is 324. So this is 324. So this implies how much is h? H is square root of 324 centimeter, which is equal to 324. What is the square root of 18? So this is 18 centimeter. H is 18 centimeter. Now the formula we have got y square is equal to 4 into x square minus h square. This is based on the Pythagoras theorem. As you can see in this triangle ABC, AE is perpendicular to BC, and AE will also bisect the side BC, that is, E is the midpoint of BC. So since E is the midpoint of BC, applying Pythagoras theorem, we will get y square is equal to 4 into x square minus h square. So we have h is this. So this implies the area, now we can say, is half the base is y and height is h. This is equal to half, y is given as 48 and height is 18. This much centimeter square. This is equal to 24 multiplied by 18, this much centimeter square, which is equal to 24 multiplied by 18 is 432. So this is 432 centimeter square. Okay, let's do the next problem. Question number 18. The base of an isosceles triangle is 12 centimeter and its perimeter is 32 centimeter. Find its area. Okay, so if I refer this picture, let me copy this figure. So we have this figure. Let's say ABC is the isosceles triangle where the equal sides are x and the base is on the other side is of length y. So it is given that the perimeter of the isosceles triangle, perimeter will be equal to x plus y, which is equal to 2x plus y. Okay, this is okay for this problem. For this problem, x is equal to, we do not have x is not given, but y is given. The base of an isosceles triangle, which is the side BC, y is given as 12 centimeter. Okay, so now we have perimeter is equal to twice x plus y. Now perimeter is given to be 32, so we have 32 is equal to twice x and y is 12. So from here we can find out the length of each equal side of the isosceles triangle. 2x will be equal to 32 minus 12, which is 20. This implies x is equal to 20 by 2, which is equal to 10 centimeter. So x is 10 centimeter. So now we can find the area, but first we need to find the height. So height h will be equal to x square minus y square by 4, because we know the formula is the relation between the base and the equal sides, and the height is y square is equal to 4 into x square minus h square, where h is the height, x is the length of the each equal sides, and y is the length of the base, h square. Okay, so this is equal to what is x. Now you might also use Heron's formula. Since we know all the length of all the sides of the triangle, you can also use Heron's formula to find the area. But I think this method, the method of finding the area using half into base into height, will be a better choice. I don't know. To me it thinks this is a better choice. So h square is x square is 10 square, y is 12 square by 4. This is equal to 100 minus 144 by 4, which is equal to 144 minus 36, which is equal to 64. So this implies h is equal to square root of 64 centimeter, which is equal to 8 centimeter. So the height is 8 centimeter. So this implies the area is equal to half into base into height, which is equal to half into base is 12 multiplied by height is 8. This much centimeter square. this is equal to 32 centimeter square. Sorry, this is 6, sorry, not 32 but 48. 6 multiplied by 8 is 48 centimeter square. Okay, let's do the next problem. Question number 19. The diagonal of a quadrilateral is 26 centimeter and the perpendiculars drawn to it from the opposite vertices are 12.8 centimeter and 11.2 centimeter. Find the area of the quadrilateral. Now, finding the, so this is a very common, this concept I did not discuss, that you can find the area of a quadrilateral. So let's say this is a quadrilateral. Let's say this is a quadrilateral A, B, C, D. How do we find the area of this quadrilateral? One standard way is that we need to know the length of a diagonal. Let's say we know the length of the diagonal BD, and also we need to know the vertices opposite to the diagonal BD are A and C. So we have to draw perpendicular from vertex A and C on the diagonal BD. So let's say this is perpendicular to BD and also this is perpendicular. So let's say this be E. So AC, AE and CF are perpendicular. AE is perpendicular to BD and also CF is perpendicular to BD. Then we can find the area of the triangle ABD and BCD. The sum of their areas will be equal to the sum of the quadrilateral. Will be equal to the area of the quadrilateral ABCD. Okay. So we can see that area of ABCD is equal to area of triangle ABB plus area of triangle BCD. Now, what is the area of triangle ABD? In the triangle ABD, BD is the base. We can consider BD as the base, and AE is the height. So this will be half multiplied by BD multiplied by AE plus the area of the triangle BCD is half. Again, we can consider BD as the base and CF as the height. So this is BD multiplied by CF. So you can see we can take out BD by 2 as common. So we have BD by 2 and we have multiplied by AE plus CF. So AE is the perpendicular drawn from vertex A on the diagonal BD and CF is the perpendicular drawn from the vertex C on the diagonal BD. And this the length of AE and CF are given as 12.8 centimeter and 11.2 centimeter. Okay, so the area and BD is also given. The length of the diagonal BD is also given to be 26 centimeter. So this becomes 26 by 2 multiplied by 12.8 plus 11.2, this much centimeter square. This is equal to 13 multiplied by 24 centimeter square, and which is equal to 24 multiplied by 13 is 312. So the area of this quadrilateral is 312 centimeter square. Okay, let's do the next problem. Question number 20. A figure is given. Find the area of the quadrilateral ABCD. So as you can see, the length of all the sides of the quadrilateral ABCD is given, and also the length of diagonal AC is given. But we do not know the height. In the previous problem, the length of the perpendicular from the opposite vertex of a diagonal were given. But in this problem, the length of the heights are not given. But if you divide, we can divide, as you can see, the area of the quadrilateral ABCD is nothing but the area of the triangle ADC plus the area of triangle ABC. And we know the length of sides, the length of all the sides of these two triangles. So we can easily find the area of these two triangles ADC and ABC using the Heron's formula. Okay. So for triangle ADC, for triangle ADC, what is the semi-perimeter? Semi-perimeter is the length, the sum of the length of the sides divided by 2, which will be equal to 40 plus 50 plus 30 divided by 2, which is equal to 60 centimeter. Okay, and so the area will be square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C, this much centimeter square. So this is equal to S is 60 multiplied by 60 minus we have 50 multiplied by 60 minus 40 multiplied by 60 minus 30, this much centimeter square. This is equal to square root of 60 multiplied by 10 multiplied by 20 multiplied by 30 centimeter square. This is equal to we have 60, 10, 10. Okay, so we have 6 into 2 is 12, 12 into 36. So this is 36 multiplied by 1 to 10,000 centimeter square. So this is equal to 6 into 100 centimeter square, which is equal to 600 centimeter square. So the area of the triangle ADC is 600 centimeter square. So similarly, we have to find the area of triangle ABC. For triangle ABC, we have 30, 28 and 26. S is 30, 28 plus 26 divided by 2, which is equal to 15 plus 14 is 29. 29 plus 13 is 29 plus 13 is 42. 42 centimeter is the semi-perimeter. I will quickly check if I am correct, or 30 plus 28 plus 26 is this. Okay, 42 centimeter. So this implies area will be equal to square root of, using the Heron's formula, S multiplied by S minus A multiplied by S minus B multiplied by S minus C, this much centimeter square. Okay, S is 42, so 42 multiplied by 42 minus 30, 42 minus 28 and 42 minus 26, this much centimeter square. This is equal to square root of 42 multiplied by 8 multiplied 42 minus 30 is 8. Sorry, 42 minus 8 is not 8, but 42 minus 30 is 12 multiplied by 42 minus 28 is 14 multiplied by 42 minus 26 is 16, this much centimeter square. So this is equal to, we have 16, we have 42 is 7 into 6, 12 is 2 into 6 and 14 is 2 into 7. Okay, so this is equal to, we have We have 16 means 4 square, we have 2 7, so 7 square, we have 2 6, 6 square, and we have 2 2. This, so this is equal to 4 multiplied by 7 multiplied by 6 multiplied by 2, this much centimeter square, which is equal to 28. 28 multiplied by 12 is 336. 336 centimeter square. So this implies area of the quadrilateral ABCD will be equal to the area of the first it is 600 plus 336. 600 plus 336, this much centimeter square, which is 936 centimeter square. 936 centimeter square is the area of the quadrilateral. So with this, it comes to an end in solving question number 11 to question number 20 from the exercise 20D, based on the from the chapter of mensuration. So all this exercise, all the problems are based on area of triangle. So the remaining problem, I think there are 4 or 5 problems I will do in the next video, which is coming soon. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So once the remaining problems of exercise 20D is complete, I will start the next topic, which is circumference and area of a circle. So please stay tuned for these videos to come soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.